friends, Christy Teji here, your host for the Productive Passions podcast. Let me ask you, is there something different you dream of doing but don't know where to begin? If you're feeling suffocated, anxious, or you feel there's something different calling you, come along with me for candid conversations with people who have embarked on a journey to put their passions to work for them. Buckle up and enjoy the ride. Life is too short to stay stuck. Hi, friends. Welcome to another exciting episode of Productive Passions. Today, we're diving into the frontier where agriculture meets the stars and technology paves the way for humanity's greatest adventures. We're thrilled to have a special guest co-host joining us, a 13-year-old aspiring astronaut who dreams of working on the moon. Join us as we explore how controlled environmental agriculture is not only revolutionizing crop productivity on Earth, but also feeding our astronauts on the International Space Station. We'll weigh the practical considerations of colonizing the moon versus Mars and discuss how advancing technology is creating unprecedented job opportunities and sparking entrepreneurial ventures in space. Imagine a future where the first human to walk on Mars is already alive today, where space agriculture is transforming our farming practices, and where space exploration is redefining recycling processes like never before. We'll take you through a fascinating history of over 5,000 years of stellar exploration and highlight how two of our biggest challenges, addressing the growing earthly population and becoming an extraterrestrial species, are also our greatest opportunities. Whether you're a space enthusiast, a tech aficionado, or just curious about the future, this episode promises to be an exhilarating journey beyond our planet. Buckle up and get ready to be inspired by the possibilities of a future that's closer than you think, guided by the dreams and aspirations of our young co-host. Dr. Gary, thank you so much for joining me on Productive Passions. And today we have a special co-host. We have Andrew. Andrew is going to join me in asking you questions today. So thank you for joining us today.
Oh, it's my pleasure.
My pleasure too.
Great. Let's get started. So, Dr. Gary, I was doing some research about some of the work you do and absolutely fascinated by it. In your words, can you tell us what is it that you do for a living?
Well, I consider myself to be a horticulturalist, which is a specialist in plant, a plant physiologist, understanding how plants work, and a space biologist. How do plants respond in the absence of gravity? So what I do is look at and develop ways to grow plants in space where there's no gravity. So water floats, soil floats. You don't know which way is up and down, and how we can do that to keep people alive as we become colonists, moving away from Earth and colonizing the moon and Mars. And then the second thing that I do and am very passionate about is taking that knowledge of this closed, sustainable systems and how can we use that to apply it here on Earth so we can meet those challenges of feeding people on Earth. So I like to say, I grow plants in space and I feed people on Earth.
That is a big job. Before I ask you about how you got involved in space, I'm curious about what made you interested in plants to begin with.
I've had innate interest for a very long time, and I think it's an interest everybody starts out with. There is children that you'll grow things and you'll get seeds and you're fascinated with things beginning to develop. And I came from a family that was involved in agriculture. Both my grandparents were in farming. My father had a farm, and he was a professor at the University of Arkansas in agriculture. One of my first jobs was out hoeing weeds and, working the field. So it comes naturally. And they're growing up in the Ozark Mountains. There's a lot of natural woods and medicinal plants. And so hiking in the plants and, that sense of ecology of how plants are essential for our long-term survival became very much implanted in me at an early age. So it came natural.
No pun intended.
Exactly. No pun intended. It was a family business, maybe.
Sounds good. So, can you explain what this controlled environment agriculture is? What does that mean here on Earth, and what does that mean for space?
It is pretty much what each of those words are. And I'll go, to backwards. Agriculture, we're growing food, we're growing plants. We're in the process of cultivating and not growing, that nurturing and tending, that interaction with the plant to produce food or fiber or medicine. And the environment is everything that's around it, the nutrients, what's in the soil, what's in the atmosphere, the CO2, the light, the amount of water, how long you get the light. And then the controlled is how we manage that. So here on Earth, the most recognizable symbol is a greenhouse. Because in that greenhouse, you're controlling when the plants are watered. You can control how much temperature is on the inside, what nutrients are provided. So you provide that controlled environment agriculture. In recent years, well, when we began looking to growing plants in space, that's everything. It's inside of a capsule. You have got to be able to, what's the air temperature? What's the relative humidity? What do you do with the gases? What about the extra gases? How do you get the water in? Where do the nutrients come in? What's the media? It is a micromanagement of biology to get it as productive as possible.
So, how does the soil and the water not float away from where it needs to be in space?
Oh, yeah, see, that's the fun stuff, is figuring that out. There are many things that have been, worked. You put it in a container and you have to seal it in. And so, in some things that, one solution we worked on, one of our very first flight experiments about 25 years ago now, was you had in the garden, had these things they called soaker tubes where water comes out. We'd do that in space. We'd have these tubes that water would put into the soil, and we had these little particles, little flat things. You'd have to put really, really tight, because we found out once we took them to space, they would all spin around like a slurry. So we had to learn how to pack them in really tight, get some foam to hold them. So devise containment systems. And see, that's part of that controlled environment. We make a little root module, and inside that are the nutrients. We keep the roots in it. There's various ways we've done it, but we've got to contain it. And similarly, which way is up? Ooh, plants don't know. But one of the beautiful things about plants, in my mind, there's multiple systems for finding things out. One, which way is up? One is gravity. Shoots start to come up, roots go down. Another one is light. Roots turn away from the light. Others, shoots go towards the light. So we will get rid of what, our techno terms, gravitropism, turning towards gravity. That goes away. So now we can do phototropism. We use light to have it turn up or down. So we use different systems. That's where understanding the plant enables us to grow in these new and unique environments.
Andrew, what do you think about that?
Well, I like to learn about this kind of stuff. I find it fascinating. And I had thought about the problem of what if the plant starts growing into the ground, into the soil that you have, but now that Dr. Gary explained it, that makes sense. That the plant would naturally go to the light.
Well, but you've come across a really good point there, that we don't know that until we began working in that new environment, because the seed has, it comes out, and if you've ever germinated a seed, you'll have a shoot come off one side and a little root. Usually the root comes out. And, many of the early tests, we didn't know which way they were going to come out. So the root would come up into the air and die. So that's where the horticulture comes in, that understanding which way is the seed going to come out. So we'd plant the seed with the rooty end down and the shooty end up. So we give it a head start.
Wait. How do you know the rooty end from the shooty end in technical terms?
Depends on the seed. Like on, say, a wheat seed, if you get a whole wheat kernel, you're going to kind of look at it. It's got a little thing. We kind of call it the crack side. We're a little more colorful on that. And then there's a little pointy end. So that pointy end down is the way the roots will come out and the shoot will come up on the other side. And
now, do all seeds have that?
Those are what they would call like the grains. Then there's others like a bean. If you look at the bean seed where you have that curve, there's a little spot there at the bottom. That's usually where the very first root will come out and start to turn down. So we'd point that at the bottom. So it's just not casting seeds upon the soil when we're going into space, because we're having to place them very carefully.
So it is not going and just tossing seeds. You're planting each individual seed, correct?
We're planting each individual seed as we're prior to flight or in flight. We will do that on some things they call seed tapes, so you can reposition them on these little things that are laid out. And they'll do that you can buy catalogs out of seed catalogs for making your garden easy, where they've attached the seeds perfectly spaced with a little bit of nutrients to get them started, and you can grow them out. So that's some of the technologies that, we were using, because seeds float around. So you have a little one, if you open the bag, they go all everywhere, and you don't want them getting stuck up your nose. So you contain it and you take care of that as much on the ground as you can.
So you said the first time you did this, correct me if I'm wrong, was about 25 years ago. Is that correct?
Actually, the very first time I was involved in an experiment was longer than that, but that was the first one I led. Yes.
So you've had some time to figure this out and for your technique to evolve. Has it changed a lot since those 25 plus years ago?
Mine's evolved. Other scientists have evolved. There's been, certainly a whole series of experiments, and most definitely each experience in space informs the next. So some of those basics, it's still a challenge to watering the plants and the roots for lots of reasons, but the atmospheric control, the ability to get lights to the plants, the selections of seeds, getting germination, getting plants to harvest, all things that were real challenges initially are now routinely happening on orbit. So we were, I think, in recent, probably the past 2015, so that's coming on, quite some time now. Astronauts have been growing their own food on the International Space Station. They've grown lettuce, and they've grown tomatoes, and they've grown peppers. So there's been, that ability now to, can we make this happen? To, yes, we can. We can grow them, and we can make a salad and a taco.
So you talked about a lot of vegetables. How about, I would be very interested, and Andrew, ask about what you're interested too, but I'd be really interested to know about blueberries. Can we grow blueberries in space?
Ooh, can we? We haven't tried, but, my answer would be, yes, we can. What it was going to take will be a challenge. And the next question would be, really, should we? And that comes down. So if I'm going to go to Mars, and we are then looking, and we've got limited amount of time and space and energy. And so in this controlled environment, I have got to put power to make lights, and I'm giving water for my blueberry plant, and I'm putting nutrients, and I'm using, oxygen in there to keep the roots going, and I'm taking up space. If I'm growing something like a lettuce or something leafy green, I'm eating 95% of it. So all of that energy I am eating. So now so you take a blueberry, you take something like a little low bush blueberry, which is a little dwarf blueberry. So it's small and it's very productive and it's low to the ground, so it doesn't take up much space. And if you can make it, continuously produce, yes, that would make a lot of sense. And I'm a real fan of taking blueberries along because of I like them, number one. But two, they're full of antioxidants.
Right.
And these antioxidants plus are good to prevent that damage to the system when you're up in space. Radiation damage, you get changes in physiology, weld off the disease. So you have a biological life support, a biostimulant that's in your body, be a bioprotectant. So by eating fresh blueberries or strawberries or any of those fruits, you can increase your resistance to that damage that comes or those insults that can come from living in a strange environment. So,
Cool.
yes, I think you can. I haven't actually done it, although I did work on a project where we were trying to grow, dwarf plums, trying to select dwarf plums to fly in space for those same reasons.
Andrew, you had a question?
Yeah.
Yeah. Do these plants count as extraterrestrial life forms?
Ooh, that is a really good question. They would not be, because at this point they've started on Earth. So they would be, they started on Earth, gone to space, and come back. So that's a really good question I'll have to think about, because if these are extraterrestrial plants, that would mean all of the astronauts now that are on orbit are extraterrestrials when they come home. So, I don't know now if, when I meet an astronaut at reception, are they an extraterrestrial or not?
Andrew, great question.
That is a great question. I have to think about that one. So if we grow, so let's say I start growing plants on Mars, and then I bring them back and they've gone through multiple generations. They've adapted to Mars, but their parents have all come from, Earth. Are they extraterrestrials? Or, that's a really interesting question. It begs to a science fiction book I read many, many years ago. Well, find one, Stranger in a Strange Land. It is a good question.
That's a really exciting question. Did you have another one, Andrew?
No, not really.
You sure? Okay. So I was going to ask you, Andrew, when you think about exploring space, I believe your generation will actually be the first to live and colonize on a different planet. What do you see as, whether we should, whether we shouldn't? What do we gain from it? Do you want to be a part of that or not? What are your thoughts about that? You're going to be at the forefront of it.
I definitely want to be a part of it. Definitely, we need to choose where we're going very carefully, because if you go to, let's say, Mercury or Venus, you're going to be spending so much money on just surviving, let alone getting anything done. If we want to go somewhere or do that, I'd say the moon would be my first choice, not Mars, because the moon is closer. We can get there relatively quickly. We can we've thought about pulling asteroids into the orbit of the moon to mine them, since they have quite a lot of minerals in it, so we can use that as our basis to fund other projects. And the moon is just chock full of resources. So that would be my pick. And then probably my next pick would be Mars, because it's the one we know the most about, but I still am more hesitant to go to Mars, because to get our astronauts there quickly and quickly back, there's a 2-year time gap between the sweet spot to send them to where would be the shortest time. It's a 2-year time gap between that, which is why I prefer not to.
That's really good thoughts, and that's pretty much the plan that NASA has put together and other groups, that would go to the moon first to learn how to do things. You practice, you make your mistakes when you're a couple of days away, versus on Mars, where you're very correct. It's like 9 months to get there, and then it's about 18 months and 9 months to come back. Technologies may change to shorten it, but in any event, it's still a long ways to go. Some of the challenges that come up with both of those and doing one than the other, like the moon, is it seems like, oh, okay, it's close, it sets up. But then we have all of these challenges with lighting and control and resources that you don't think about it, or I hadn't. But I'm here on Earth. I have, a 24-hour day. Roughly, I'm living in Florida, so my day length goes from about 10 hours light to 14 hours light, then some dark. If I'm further north, it's shorter or longer. But on the moon, a day you have 14 days of light and 14 days of dark. Because as you're starting those phases of the moon, when it gets dark, then it gets light on the other side. So that requires lighting. We've got protection. There's different minerals in the regolith. Or on Mars, which is attractive for this kind of thinking, is because there's water there. And the day length is pretty close to what we have here. It's about 26-hour day instead of 24. So some of the things that people have adapted to or the plants have adapted to can use that natural environment from the sun as part of those triggers. But that's a really good thought process. So thank you for sharing that.
You're welcome.
Very, very good question. Andrew, do you have another question?
No, I don't have any.
I have a couple, Dr. Gary.
Okay.
What are some of the lessons that you're learning working in space that can be applied here on Earth?
I'm glad you asked that question because there are a lot. I'm going to backtrack before I fully address that question. I originally went to go work at Kennedy Space Center. I'd been a professor at the University of Maryland teaching horticulture, apples, peaches, plums, and pears, some greenhouses. And the opportunity came to work on this project at Kennedy Space Center that was part of what they called the breadboard project, or controlled ecological life support systems. And its objective was to demonstrate that we could keep one person alive for 1 year using biological systems, plants. And the four things that we looked at that we need to stay alive are, well, every time I breathe out, putting CO2 into the atmosphere. And if we're all in this closed room, after a little bit, we will begin to get tired and sleepy and not wake up because we have suffocated from too much carbon dioxide. But you can scrub that out using some chemical ways. So if we get that out of the way, we can stay a little bit longer till we don't wake up because we've now died from lack of oxygen. Ooh, not good. But if we make that, we can go a little bit longer till we get very, very cranky with each other and we end up not moving and dying from dehydration. But if we can make the water from resources, we can go even longer, then we get really cranky before we wither away from starvation. But so the idea was those are the four things we need to have for life support. Remove the contaminants from the atmosphere, regenerate, purify water, and produce food. And plants do that. Biologically, at normal temperatures, taking a deep breath, it worked this morning. Light from the sun was hitting the chlorophyll of the leaf and through photosynthesis took carbon dioxide and converted that into oxygen. Plants through their roots will take out nutrient-rich or contaminated water, transpire it up to the top of the leaves, and when it rains, they've done their job. They've generated fresh water through a process we call transpiration. So if I can control those in a chamber with lights and temperature and the environment, I can produce food. So that results in a closed system, a sustainable life support system, a biological life support system. And that is what Gaia, or Mother Earth, is. We are in a life support system where plants are regenerating the oxygen. They're producing the oxygen. They're transpiring, and the water cycle and they're producing our food. So that closed, sustainable life support systems, the lessons we learned for that have applicability here on Earth in lots and lots of ways. A couple of things from that project. During those first years, we're learning how to do it. We were pushing the limits. We found just how productive these crops we grow, here on Earth can be. They're growing lettuce. We're at 20% higher yields than anybody thought possible with some of these varieties. They since changed the models. We were growing wheat, 4 times world record field yields. Potatoes, we were twice world record field yields in 2/3 of the time. So by providing, understanding what that plant needed, giving it to it at exactly the right time, we can push those limits. We're not recreating a system, but we're providing that optimum conditions that existed. A couple analogies, I like to use. One is athletes. Everybody has some innate potential, but with some training and optimal conditioning and optimum environment, we can push what was to what can be.
So if we think about the Olympics going on right now, it's almost like an Olympic athlete, right? I'm not going to be able to go out there and win a gold medal in swimming. But if you give me the right conditions, the right foods, the right training, all of the things that need to be a great swimmer, I might have a better chance to be that Olympian swimmer. Is that sort of what you're talking about?
That is very much what I'm talking about, except that, where we were starting, we know what we can do in a given environment. I know when I just go out and run by myself, and I knew what I could do by myself. Then I got a coach. Okay. Then a coach was able to fine tune, what I did, optimize it, make some suggestions. And to the extent that I'm able to follow that, I improve. So now I know what my full potential is. Mm. So the decisions that we were making 25 years ago, I said, oh, this is what we can do. Now, what's a better candidate? What's a better variety? What's the better species for what my end goal is? And I can push that to its limits. And, you're pushing systems as hard as you can because your resources are so limited. So you're trying to get the most out of them, but sustain them and not break them. And I think that's a problem that we come back here on Earth. We're pushing systems as harder than they can sustain, and we're breaking them. And an analogy I use that's not really a perfect one is like NASCAR, where you're like, I like watching the races. But the difference between an optimum tuning of that engine and a blown engine, is just a few torque somewhere. So, our goal is to know where that break point is, operate at some level of sustainability. Because what is the level of operations that I can push a plant or a system to keep us alive for that 3-year journey that we're going to have on Mars? Because we're going to be drinking that same bottle of water for 3 years. We're going to be eating that same food for 3 years. Just closed system. And in a closed system, we've got to start thinking of all of our waste, the leaves, the stems, the packaging, the paper. I mean, they're not waste. They've got to be there. You've got to deal with it. So they become resources. What's that a resource from? Oh, you get the nutrients and you recycle. Our wastewater, our pure water that comes out not so pure, but it's got nutrients in it. It's got other material. What's that a resource from? We can use the plants to
now,
purify that.
When you're talking about that, you're talking about when we urinate. Is that right?
I'm talking about urine. I'm talking about urine. I'm talking about wash water. I'm talking about shower water. I'm talking about gray water.
So we need to figure out in those kinds of waters that sometimes we would go, ew, that there is some value in there. Is that correct?
That is absolutely. So everything that comes in comes out one way or another. We don't Andrew will add some mass, over the next few years, but rest of us pretty much stays same. All the water that we have goes in, either goes out as sweat or perspiration or urine or, various ways. All of the food comes out is either heat or energy or comes out as, solid waste or fecal matter. That's all rich in nutrients. So how do you recover that and reutilize it? Otherwise, do you have, our calculations are it's roughly where we're at 30 kilograms. So it's about 60 pounds of inputs come in every single day in terms of oxygen and water and food.
So, Dr. Gary, I could see
Yep.
that this is probably a place where kids would get really excited, not just kids. I guess I'm a big kid too, and go, oh my gosh, you're talking about using urine, pee and poo for good.
Pee and poo.
And
absolutely.
And so are you teaching the astronauts how to use pee and poo for good?
Yes.
And so
it's a hard sell.
What do they have to do, and what is the good?
So let's start with the pee. You have water. So you remove the salts, you've got the elements out of it, so you're recycling water. That means your ability for your life support to continue living and drinking. So if you can't get your resupply, you're going to have to recycle your water. So you reuse and you clean your water. If you have a long mission, that's fertilizer. Most of the world uses manures as fertilizers on their crops.
And the manure is the poop.
Manure is poop. That's poop. Poop. There's a whole number of things. But
you have a question, yes. Andrew?
More of a statement. The International Space Station has been using the technique to essentially turn urine back into the drinkable water for a while. Are we using that water on the plants, or is it just...
No, that's for the crew. That's for the crew. And I think certainly some of that has been used on the plants. Each experiment's got to take their own supplies. So it's an accounting, but yes, it's been used for the crew. It's been used for the plants. It's pure, what we call portable or drinkable water. It is safe to consume. And we use so much water and it's so heavy that it becomes expensive to send up a gallon of water every day. So it is cheaper, more efficient, and sustainable to continue reusing that water. So how does that apply here on Earth, which is where we started this question, was now you can take wastewater, you can run that through, either some cropping systems to take out salts and minerals and nutrients to purify it as it goes. Here where I'm living, there's a wetlands water treatment system. So it's a biological treatment of water. And you can turn that into food. You can use that for irrigation and water. So you're using recycling. It's one of the real resources that are going to be limiting for, future growth and sustainability here on that planet is water and of land and of nutrients. So another digression along those same points. I think in Andrew's lifetime, hopefully a portion of mine, there's going to be another 3 billion people on this planet.
That's billion with a B. Correct?
Billion with a B.
That's a lot of people.
That's a lot of people. And the human mind has a hard time separating, the difference, that a billion and a million, it's got 3 zeros. So it seems like 3 times as much, but really it's like 1,000 times as much. So to give you some context, that's the population of all of North America, South America, Europe, Australia, and Japan. And they are all
Dr. Gary, that's a lot of people.
And they're all coming to dinner.
Andrew, we better start cooking.
Exactly. We are setting the table for them now.
Yeah.
The technologies that are developing now are going to be the solution on how we feed those people.
Dr. Gary, excuse me for interrupting, but you just made a point that I want you to say again. There's always a point in my interviews where I want to hit rewind so people really hear that point again. Could you repeat what you just said about what's going to happen in the future and what needs to happen now?
If I can remember it, but what I do know is we are going to have population of North and South America, Japan, and Australia are all coming to dinner in the next 30 years. And we're setting the table for them now. The technologies and the solutions that will address how to feed those people are being achieved now. And there are two things that are going to happen. I am certainly in Andrew's life. One, we are going to have those 3 billion people, and that is going to become a threat, a challenge for our humanity, how we are going to address our neighbors, what our humanity is, on how we address that problem on a global level.
Yes.
The second thing that's going to happen is we are going to go to Mars. There will be a human being on Mars. That person is walking the planet now. They are alive. And that will fundamentally change the way we perceive ourselves as human beings. We will become truly an extra, planetary species. We will become extraterrestrial species. And how we address those two challenges simultaneously is going to be kind of the yin yang of the push and pull of the coming generations. How do we focus on the issues at hand without stopping dreaming of the future and the stars and beyond, that age-old mystery that has kept us looking to the stars, what is out there, and understanding it.
Andrew, you had something you were going to say.
Yes.
One of the ways, and I think we can relate to this, is that on the Apollo 11 mission, when Neil Armstrong stepped out onto it, it wasn't officially the end of the Cold War, but it's when, everybody was like, okay, well, our battle doesn't matter. We don't need domination. We have somebody stepping on the moon, walking on the moon. Everyone on Earth was amazed. And there are patches. The Apollo 11 patches were made. They didn't have an American flag on it. They didn't have something that represented that. They just had an eagle carrying an olive branch.
Yep.
And I find that the patch wasn't like, we are Americans. Americans claim the moon. It was, humanity is now here. We are now a very technologically advanced society.
No, that is a very, very astute observation and very point on. That moment brought together 50% of the world that had access to that imagery. It was just black and white TV was watching that moment. So it's one of the few moments of unity around the planet. So that is the power of space. That is the power of exploration. And, that technological advancement was a culmination of a very, very, very long journey. And that journey, as I've seen tablets that were, they tell me that were, from the Babylonian civilizations, 5,000 years ago, where they are mapping the movement of the planets. They were scribes that understood the circles of the orbits. They could predict eclipses, where the worlds were at. It took 2,000 years, right? Longer. I think, closer to 3, before the technology developed with the telescope and the lenses, so that Michelangelo could look up and began to map that there were parts of that on Mars, where you began to see, snow caps on it, and he had the rough outline there of canyons. The technology got better. It was still another 74 years where they started mapping out all of these channels and canals, and folks started thinking, oh my gosh, there's advanced civilizations and Martians building roads and canals and infrastructure. Then, in 1916, there was the invention. Wright brothers flew across Kitty Hawk a few hundred feet, the first time in air. In less than 75 years, that moment that you had happened, going from, it had taken thousands of years to know where we wanted to go, to where we could see it, to map it, to the initial technology. And then from we just going a few hundred began dreaming, 75 years later, we have human beings walking on the moon. We are now envisioning colonies of Mars. Those rockets are being built. They're just down the road from me. They're launching off the coast. Those are being built and tested. We are going to go to Mars. We are dreaming of developing and expanding who and what we are. But at the same time, we have so many people coming in, and we're maturing. The populations of the world is getting older. So we're going to get those problems of age and ache and taking care of each other. Not only mouths to feed, but then we're not so sick and we're moving a little slower. So we have that, and people are moving into the cities. So we're not growing our own food. So the technologies that we began looking at in space to people alive have now enabled a whole industry to develop of indoor farming, where inside of warehouses, growing up instead of out, 365 days out of the year, food is being produced in the middle of cities. It is providing healthy foods that provide first the calories, but also phytonutrients, the blueberries, the tomatoes, the peppers, those things that keep us healthy. So not only are we surviving, we have the capacity to thrive in ways that weren't possible 15 years ago. And, I like to, you know, think that we had a little bit to do with that transformation.
Dr. Gary, I have a question. When I started preparing for this conversation, one of the things that just kept going through my head, you touched on it just a little bit, we're kind of getting there. What do you see as the future of farming and farmers on Earth? What's going to happen to the farmers as we do more of the controlled environment agriculture? Are our farms going to be in the big warehouses like Amazon has, where all of those packages are?
Farming is changing, and it has, over the past really 70 years in my lifetime, almost, has, gone from being a fundamental, primary occupation of most states and most families to, less than 2% of the population is producing the food. So it has become larger. It's automated. In many ways, it's controlled in the field. There's a lot of artificial intelligence. There's using satellites for planing and precision art agriculture for most of our grains and our foods. And, there's, a lot of discussion about, the benefits or, impacts of that. That's where we're at. So, as we began becoming more urban, a part of that agriculture, and I think an important part where we're looking for these fruits and vegetables that give us these antioxidants and things that keep us healthy, are going to be going into some warehouses because you can control the supply. COVID brought to light the incredible value that had been developed by this global network of food producing and going all around the world. But when that broke, there we were left with no resources, no
Yeah.
ability to get it. You couldn't transport it. Things that were meant, they couldn't move from where they were grown to where they needed to be. So these warehouses and indoor agriculture and controlled environments allow the food to be grown where it's needed, where it's used, and where it's consumed.
But where are the nutrients come from? Because I always learn nutrients come from the soil, that comes from the ground. So if we're got a cement ground, where are our nutrients coming from?
So the nutrients can come from a lot of places. Much of the nutrients that go in the field, out in the soil. If you're driving and you see in your garden, they'd come from fertilizers that we'd put into hydroponics, which is without soil. So you put that in. As I mentioned earlier, you can recover much of the nutrients, very much not utilized to the extent possible, from our inedible biomass, our leaves, our stems, our compost. We leach those out. Those things are garbage, our waste, our sewage. You get the nutrients out and you can recover the nitrogen and the phosphorus. So instead of that going into the lagoons or the water supplies, that now it can be recycled and reused. So you become a recyclable, sustainable life support. We're not there yet. There's a long ways we have to go. But there are systems now that are, recycling water inside these, large facilities. They recycle, they reuse the water. It doesn't evaporate off. They're recovering it from, the air conditioning systems. And so you're reutilizing, so you're preserving that resource of water.
Gotcha. Andrew, how old are you, if you don't mind my asking?
13.
13. Dr. Gary, when you were 13, what did you want to be when you grew up?
Ooh, that's a really good question. I don't know. I was moving around a lot. I was working in fields, so I think I just sort of assumed, about that time, I thought I was going to be some sort of, ecological warrior going out to, save the planet and, keep the forest from being cut down. But I don't remember.
I don't think you're too far off of that dream, Dr. Gary.
Well, it looks different than what I thought I was going to be doing.
And I think that happens.
That 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 does happen, because in much of the ways, I was a little older than 13. But I remember listening to somebody talk about, the problems there in the rainforest, and carbon dioxide was starting to go up and the impacts those were going to have. And okay, so you fast forward a few decades now, and where the rainforests are still being cut. The CO2 has gone up from almost doubled in my lifetime. We're seeing consequences of that. There's lots of arguments of, okay, where's it come from? Da, 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 da. I don't want to get into that here. But what I do know is, as a agronomist, as a horticulturist, and someone that cares about how we're going to feed those 3 billion people, I need to know how to work with that system, understand those resources that are getting limiting: water, soil, space. What are the demands are going up for food, water, nutrients? How are we going to solve this, intractable problem? What are the new solutions? What ideas can, I plant so Andrew can take what half-baked ideas we can come with to flesh them out, season them, work them out into solutions that are applicable in the world where he's coming. And there's so many new tools that have come out to assist that were, unimaginable. So, there's going to be a lot more tools, but there are going to be other problems. They're fundamental. People don't like to work together unless they like to be each other. So you're dealing with different people, different cultures, different places, limited resources. So we all have to eat drink and be healthy. One of the things that I'd like to bring up is when we go to space, how do we stay healthy? How do we stay alive? And that's what biological life support is. There's a lot of things that change up there. And I've been, blessed to be able to be a part of some of that. But when we come, here on Earth and we start getting displaced, we think about, what's it going to be like living on Mars? A choice that we made. There's a lot of people that are displaced from an environment, either through refugees or famine or war or lack of water, being taken from an area into a large city, a completely different environment. How do you adapt to that? How do you adjust? And one of those things, in Gary's view, are the plants and the foods. We solve problems over food. We comfort ourselves with food. We build community with food. We maintain culture with food. So things like these indoor agriculture have the possibility of taking the plants that don't have, global economic markets, yet are important for your particular culture, your particular ceremony, your particular flavor. So even though I have been displaced from where I grew up, where my ancestors are, where my culture is anchored, I can have a link to my mother, my grandmother, my great grandfather, to the foods and plants that have carried on. So I can assimilate to a new world, but not lose my identity.
So interesting. Something I hadn't even thought about. Andrew and I are family, and in our family, blueberries have a bit of significance.
Tell me about it.
So interesting that I hadn't even thought about. Not just Dr. Gary does really cool things like grow plants in space, but if I am going to be that astronaut or extraterrestrial who's going to live in space, I'm probably going to want some of those flavors and textures and foods that comfort me, like you were just talking about.
Yes.
It's so interesting. I realize as we have been talking, I've been taking some notes. We have been talking about lots of different types of work. So this podcast is all about productive passions, what people like to do, their jobs. We talked about space. In space, there's a lot of different kind of people working in space.
Lots and lots. Yes.
Maritime, and in an upcoming episode, we're going to talk a lot about maritime careers, but you need people. SpaceX is landing those boosters. And so you need people working in the maritime industry.
Right.
We're talking about agriculture, obviously. We're talking about warehousing. We're talking about farming. We're talking about AI. We're talking about all kinds of science.
Yeah, talking all kinds of science. Exactly. You're talking logistics. You're talking supply.
Logistics like we've never known before.
Huge logistics. You're talking about anthropology. You're talking about ergonomics. You are talking about communications. You are talking about communicating this experience. You are talking about psychology. You're talking interpersonal relationships.
Medicine.
You are talk medicine. Can you grow your own medicines? What medicines last? What do you take off? There are new ways of doing, telemedicine, types of support. There are how to, these 6 or 8 emissaries of our species that are going to Mars. How do we support them? How do we communicate them? How do we train them to do all the things that you take care of in a given day? How do we build that? How do they become sustainable, a self-sufficient colony while tethered here to, Mother Earth? How do we send our emissaries? How do we let them go, but still provide support? It's a very interesting analogies that can be made, and a lot of thought processes that can go into it.
This little conversation has opened up a whole can of worms. And Andrew, I am so curious. Given this, part of the reason you are a co-host today is because of your interest in space. And I'm wondering, given the conversation, everything we've talked about and all the what could be and what's needed, what are you thinking that you want to do when you grow up? Not that we're going to hold you to it, but I'm just curious.
Go to the moon.
So,
I want to go to the moon.
What are you going to do when you're on the moon?
Lunar Geology.
All right.
I've thought about it.
For people who are listening who don't know what lunar geology is, what does that mean?
Studying the composition of the rocks on the moon.
And how is that going to help us?
Well, if you know what we have on the moon, you know we can mine and take out and use and all sorts of things, because if you don't have the supplies to make the stuff, even if you have the technology, if you don't have the supplies and resources, you can't do any of this.
So we won't go down this rabbit hole, but I think there's a whole lot of other jobs, because if you're going to be mining on the moon, you're going to have the equipment that'll be able to do that.
You got to have the equipment, and you got to have spacesuits, because if you step outside, you're going to blow up. Freeze dry and blow up. Exactly.
And for people who aren't seeing, the reason I chuckle is Andrew kind of drew a line across his neck, because that's what
exactly
happens.
What would happen.
If we opened the door to the space container that we're in, our vehicle, in our regular bodies, we're not going to do very well.
You're going to get sucked out, burned and frozen, and then suffocate.
Right.
So there you go.
So what Andrew has brought up is a whole area of real interest, and we kind of touched on it, that they would call in situ resource utilization. But in reality, what that means is use the resources on the planet to keep you alive. Anything that you can use there, you don't have to take with you. So how do you first got to know what you have to learn how to do it.
And what was that word?
In situ, INSITU. It's Latin, as a lot of these things are. So using what's there. And if you think about the expeditions, that we learned in school, or in the fame, Lewis and Clark going west, or, Livingston into the heart of Africa, that was to collect knowledge about what was there, to understand and send back reports. What do we have? Where are rivers? Where are food? Where are plants? What is growing? And from that became the ability to build larger expeditions, to move things back and to colonize. And, here we are. So we're in the very, very early days of understanding how we're exploring, how we're getting to the moon, how we're getting to Mars. But there have been multiple missions by multiple countries landing on the moon now. There are official efforts to land humans on the moon. There have been 14 satellites doing the reconnaissance on Mars, mapping it. They're on it, drilling in it, looking for water, looking for minerals. We're doing our due diligence. We're going to go. I'm glad to know that, Andrew is going to be a part of that.
I am too. And you know what I'm really excited about, Dr. Gary? What Andrew's conversation is going to look like with people who are younger than him when he gets to be our age. Wouldn't that be fascinating to be able to time travel and listen in on that conversation?
You're going to be talking about, the archaic things that we were doing, back at the turn of the century, because it's going to have so many clever people using their creativity. And I know we're running some time, but there's this sense that creativity are painters and artists and writers and musicians, and the artists are making the money and creating new things. But it's in these realms of science and engineering and thoughts and imagining what can happen and creating to these new solutions, creating that creativity, creating new ways of doing these very, very basic things to keep us alive, to let us breathe, to let us eat, to let us move, to process our waste, to keep us healthy. These solutions to what is required to keep us as humans beings alive, living, and thriving, not only on the moon, but here on this planet that we call home.
Thank you, Dr. Gary. Andrew, I want to hand it over to you to see if you have any last questions you'd like to ask.
Nope, nothing.
Dr. Gary, any last questions or thoughts that you want to leave with us?
I think that the last thought is that, truly we're going to have two momentous challenges and opportunities in the coming decades, certainly in Andrew's lifetime. We are going to go to Mars. We are going to redefine ourselves as a species. We are going to redefine, what can be dreamt of, implemented, and created. But at the same time, we're going to have the challenges of 3 billion people to feed, an aging population, a changing climate, limited resources, urbanization, that we have got to not look just to the stars and pretend that our challenges on Earth don't exist. But if we focus on all of the challenges on Earth without dreaming and looking to the stars that have guided us as humans for, since they define our humanity in many ways. We give short thrift to both. So, continue to dream, but keep your feet firmly in the ground, working and doing one little bit at a time, little by little, bit by bit, poco a poco. We will get to where we need to be.
Well said. Dr. Gary, Andrew, it has been my pleasure to have you two on this show with me. Thank you so much for your time talking to me, but also talking to our audience. I hope that this episode inspires people to think about not only the jobs that exist today, but the ones of the future.